Okay, so let's find all the primes that add up to 50.
Well, all right. So let's start. You can start systematically and start with the smallest one that works.
Okay.
3.
347.
347.
The 5 doesn't work, so we have.
How do you know 5 doesn't work?
Because
5 and 45.
All right,
it's
and what's the
multiple of
problem?
5. And 45 is divisible by 5.
Yeah, 45 is divisible by 5.
So you can do 7 and 43.
7 and 43.
11 and 29.
39.
3.
11 and 39. Does that work?
No, it doesn't work.
Why not?
Because 39 is 13 times 3.
Oh shoot. Okay, so 3 and 7 work though.
So 13 and 37
That
works.
Works.
Okay.
17, so that's 33. 17 and 33 doesn't work.
Rats. Right.
19 and 31 work. That
Oh,
works.
19 and 31. Okay.
How about 23 and 27?
That doesn't work.
No.
And then 29,
And 29 and 21 and
that'll be.
then we're just cycling back.
Okay.
So there's gonna be these and then flip those around.
All right. So should we count them twice?
Well, yeah, no. Because we're just looking for 2 primes. We don't care. Like, we're not looking at prime X and prime Y.
Right. We're just looking for 2 primes. So
Yeah.
counting them in pairs is fine. So it turns out there's 4.
Okay.
Alright?
To add up to 50, and we could do this for other numbers, and then we ourselves could make a picture of that comment, right?
Yeah.
Do you know any other unsolved problems about prime numbers?
There's the twin prime puzzle.
All right, what does that say?
Are there infinitely many twin primes?
Yeah.
Which are primes that are one away from each other. Or like have a space between each other.
Okay. Yeah. Actually, I'm glad you brought that one up, because we can use the same argument that David Eisenbud is making to show that there probably are infinitely many twin primes. You ready to see that?
Yeah.
So he said the probability of n being prime was approximately 1 over log n, right?
Yeah.
Because there were n divided by log n primes up to n.
Yeah.
Okay? And since log n doesn't grow very much, what do you think the probability of n plus 2 being prime is approximately? This is n.
Basically the same
Pretty
thing.
close.
Okay? So what's the probability that the 2 of them to both are prime, roughly, do you think?
It's going to be 1 over ln times n squared,
That's right.
roughly.
So roughly speaking, we should have that n and n plus 2 are prime, should be both prime, approximately 1 over log n squared. Okay?
Yeah. If you multiply the probabilities.
Yeah, so the number of prime pairs like this, twin primes, less than n, should just be n over log n squared. So remember, n is much bigger than log n.
So
This approximation goes to infinity as n goes to infinity. So this is using the same type of approximation that Eisenbud used. And we remember, he said you have to be careful with this because this isn't quite right, but it's close. This would lead you to believe also that there must be infinitely many twin primes. But again, nobody knows. So there's a lot of unsolved problems in number theory that are easy to understand, but very difficult to tackle.
Yeah.
All right, good work, guys.